Hi, welcome to Mathmaxtra. This is Saritha. Today our topic is Pythagoras theorem. What is the statement of Pythagoras theorem? In a right angle triangle, you take one right angle triangle, so in which the hypotenuse square is always equal to sum of the squares of the other two sides. So what is that? You take one right angle. This is a right angle. This is ABC triangle in which the angle B is equal to 90 degrees. The side opposite to 90 degrees we call it as hypotenuse, and this is a side one and this is also another side. Okay, so what is that statement? Hypotenuse square, which is always equal to sum of the squares of the sides, other two sides. Yes. So this is the statement of Pythagoras theorem. This is also called as a Baudhayan's theorem also. Okay. So in the converse of Pythagoras theorem. In the converse of Pythagoras theorem, what is the converse of this? See here, first we have considered a right angle triangle itself. Then we are concluding that this is hypotenuse square is equal to side 1 square plus side 2 square. If the converse is what? If this condition satisfied, means this hypotenuse square is equal to side 1 square plus side 2 square. If this is satisfied, then the angle must be right angle. That is nothing but it must be a right angle triangle. So that is the converse of Pythagoras theorem. So we'll see some properties of similarity. Okay, properties of similarity. See, is similar to is nothing but similarity. So this is always a relation, and every triangle is similar to itself. Similar to itself, and the third property is, see, if triangle ABC is similar to triangle ABC, what we call this property as it is a reflexive property. Reflexive property. If triangle ABC is similar to triangle PQR and triangle PQR is similar to triangle ABC. So what we call this property is, it is a symmetric property. So it is a symmetric property, and if triangle ABC is similar to triangle PQR and triangle PQR is similar to triangle DEF, then triangle ABC is similar to triangle DEF. So this what we call this property as, it is a transitive property. It is a transitive property. So as this similar to relation is reflexive, symmetric, transitive, it is following these three properties. So that is why we called the similar to is an equivalence relation. We said it is a relation first, then it is following these three properties. That is why we call it as it is an equivalence relation. So similar to is what? It is a equivalence relation. Okay, these are some properties of similarity. We'll see some points about similarity and congruency. Okay, we'll see some points about similarity and congruency. See, you take one triangle. This is a ABC triangle. So you take the midpoints of all the sides. These are the midpoints of the sides, which are nothing but D, E, F. If you join these three sides, you join DF, you join DE, and you join EF. Okay? So what happens? As these two are midpoints, this DF is parallel to BC. Yes? Okay. We know these angles, so we are considering this angle as a x degrees, this angle as a y degrees, this angle as a z degrees. Okay? See, as these two are parallel lines, so what happens? This is a transversal line. This angle and this angle are equal, corresponding angles. See, what about this? And these two are parallel lines. This is a transversal. So these two lines are equal, which is y degrees. Okay, then you take DE line. This is parallel to what? AC, right? So this is parallel to AC and this is a transversal. You consider this angle and this angle are corresponding angles. Yes. What about this angle and this angle? These two are also corresponding angles. These two are equal. And you take next EF, which is parallel to AB line. So the same way. So this is a corresponding angle. This is a transversal. This is a corresponding angle Z degrees. And this is a corresponding angle X degrees. See, what else left here? Z degrees. And what else left here? Y degrees. What else left here? X degrees. So you see each triangle, you observe. So by joining these three midpoints of the sides, we have formed four triangles, right? So you observe these four triangles. What happens? All the angles in the four triangles are equal. Angle, angle, angle axiom. You identify. So these four triangles have equal angles. That is why these four triangles are all congruent to each other. All angles are equal. See, x degrees, y degrees, z, x, y, z, x, y, z. See, yes, these four triangles are congruent to each other. So that is the point. First point is what? If you join the midpoints of all the sides, the four triangles are formed. Those four triangles are congruent to each other. And each triangle in the four triangles that is similar to the given triangle, which is a triangle ABC. So what we are saying, see, the triangle ADF. So you take this triangle ADF, which is congruent to. So this is the first triangle, triangle ADF, okay, which is congruent to triangle DB, which is congruent to triangle EFD, which is congruent to triangle FEC. So these are all congruent to each other. These are the four triangles formed by joining the midpoints of the sides. And these total, all triangles are similar to what? Triangle ABC. So this is our given triangle. So each triangle are similar to this given triangle. Okay. So this is one point. So if you continue by taking the midpoints of all the sides in this also, you consider these are the midpoints of this. And if you join, one more triangle form, four more triangles formed. So if you join these 3 points, four more triangles, four more triangles, four more triangles. So if you keep on joining the midpoints of the triangles, infinitely many triangles are formed. These infinitely many triangles are similar to each other. All the triangles are similar to each other. So this is the second point. Okay. So by remembering these statements, we can solve many questions. See, the means we need to identify where to apply the given properties. So we have many properties, right? So for triangle, we have many properties. For similarity, congruency. So for each concept, we have many properties. So even if you remember all the properties, if you don't apply it in the correct time, then they will no use. So you understand the concept, you remember the properties and the some conditions it follows, then you apply them in the correct situation. Okay, you apply all these properties in the right way, that time you will get the answer easily. So what all you need to do is thinking and relating each and every concept, then it is easy. Okay, thank you.